There's YouTube. Is Twitch gonna come up? Let's see. There we go. Okay, looks like everything's up. Got back a little later than I thought I would, but it's all right. I'm still trying to figure out a good schedule. So, before the break, I was working on compute shaders, and I just got compute pass working. Okay, so now I have some to-dos. I need specialization constants, push constants, synchronization, and then instance and material indices buffers. Okay, well, this is probably the simplest one. So instance indices here. Yeah. So let me think how I actually want to handle this. So, so like cold instance indices, this gets written to by the compute shader. And so I just need to make sure that its size is the same as instance indices. So I guess somehow I need to like link them together so that whenever instance indices gets updated, whenever it gets resized, not updated, when it gets resized, then cold instance indices will also get resized, and the same thing for materials. So, okay. Also, yeah, so create buffer. Yeah, so let me call this instance indices and material indices. Yeah, and then if I look in the shaders, yeah, because this takes in instances, uint instances. Hold on, that doesn't seem right. Graphics. Yeah, this is instance data instances. Okay, so this should be like instance indices. Not sure how that ever worked in the first place, but okay. Yeah, it's a whole bunch of uints, which makes sense because that's what this is. Okay. Yeah, that's fine. Yeah, that needs to be instance indices. Instances, yeah. C's. There we go. Then index is visible. Yeah. So this gets, get the current thread and then check if, less than instance count and is visible. That gets the object. So this shouldn't be object data. Yeah, that should be instance data and some model matrix. This is translation, rotation, scale. Okay, I'm just modifying scale x, scale y, scale z times 0.5 to get a radius. Yeah, I'm going to get rid of all this code anyway at some point. I do have another branch for doing culling with oriented bounding boxes. I'm just trying to do it with spheres. And yeah, this is not great. So yeah, I'm just gonna place this anyway. Yeah, so instance data. And then this is instances. Instance data. Actually, I'll put this first and that second, and how am I? Is that STD 140? It is. Okay. Yeah, and what's nice about the render graph stuff is I can just like change the bindings of these, and it doesn't matter. It'll figure everything out on its own. It's awesome. Yeah, and then so this doesn't have scale or anything, right? So it's like instance data, and then I'll just have uniform scaling. I'm just gonna set radius to be 1. It's not gonna work right for now, but like the culling will be broken, but I want to get the compute shader working, and then I can adjust the visibility function. Okay. Yeah, everything else is mostly fine. So constants, yeah, so I need all this stuff. Okay. And eventually most of this I won't need because I'll be using bounding boxes, but for now I need to at least load this stuff up in compute shader. So let's go ahead and do that. And honestly, the easiest way is probably, so like I can make a struct that describes it, but I don't have to, which is nice. Oh yeah, and I want to get this working right. Yeah, this is probably more important, getting this working first. So yeah, that's instance indices, and so that's fine. But let's do this. Right, and so we've got this auto cold IDs, cold instance IDs, auto cold material IDs, and this is cold instance indices, and this is cold material indices, and maybe for the moment I can just say, like, at the start of the frame, make sure that the size is equal to this size, or at least bigger than it. Yeah, that's probably fine. So then I'm gonna, what's this type? This is a linear allocator on a GPU. So let's put this here. Linear allocator, or linear allocator on a GPU allocation. Call this cold instance indices, and then the same thing but for cold material indices. And then you're not a linear allocator, you're contiguous fixed on top of that. Okay. Contiguous fixed. There we go. And then this is cold instance indices, and this is cold material indices. And then, yeah, right before I render, I want to look at this bug. So I want to say GPU allocator get buffer instance indices. Actually, yeah, I don't even need an allocator on top of these. I just need the buffers to exist. Yeah, because I'm not allocating anything there. Yeah, so literally all I have to do is create a buffer. I don't even have to. I don't even need these. Yep. So get buffer instance indices. Yeah. And then I want to get this thing's size. Yep. And then I want to get the buffer for cold instance indices. And I want to, yeah, I can realloc. So yeah, I'll just realloc with that size. And let me put this into a nice little lambda function. Match size equals this. Ask by reference, and then this will take a string. Call this I don't know, main size reference, and then Or no, not, yeah. String, let's call this, I don't know. Can't figure out a variable name. Read size, write, or read buffer, write buffer, I don't know, whatever, it doesn't matter. Read buffer, write buffer, yeah, let me say size t, size equals this, and then GPU allocation, buffer name, TMP equals this, and then if TMP size is less than size, then TMP realloc size. There we go. Yeah. Okay, and then I can just say match size between instance indices and cold instance indices, and then material indices and cold material indices. Okay, that'll work. Yeah, that's good enough. I might need like a memory barrier or something here. Oh, wait a second. So this is running before render, right? And then render graph render is when, yeah, it updates the descriptors here. Or yeah, like when it calls render or whatever. I don't like this in here, but yeah, it updates the descriptors, whatever here. So that's fine. I can do that there. Okay, so that should match the sizes of them. Yeah, so that's good. Yes, materials, material indices, instance indices. Okay. If I look back at this shader, like this, something, yeah, am I calling materials? I thought I was. Cold material indices. Yeah, I am. Okay. Yeah, and I might need to update this shader because for like figuring out how many instances are visible, I might need to redo how this works because this requires, yeah, some kind of ordering. It's not great. Yeah, because I'm like calculating the number of visible instances between the two. Yeah, I'm like looking at the prefix sum and trying to see the number of instances difference between the two in the prefix sum, and so I have to have the previous one. Yeah, I have to have like, yeah, they have to be sorted, yeah, in ascending order by first instance, so that's not great. That might actually cause like a GPU crash or something, or device hang. Yeah, that's not great. Anyway, so push constants. So, all right, when do I do push const? Or I think it's just whenever. Yeah, it's just whenever before this, because if you look here, right, this is when it's actually going to load the push constants. Or, well, yeah, so it has this node here. Yeah. Pipeline, bind pipeline, add node. Wait, yeah, so I have like bind pipeline, but do I actually say like vk cmd compute, whatever, right? Like I have draw indexed indirect somewhere. So yeah, I think I'm missing like a dispatch. Yeah, here we go. Add dynamic node. This is when I'm actually doing draw indirect. So I do need to add the command for whatever vk cmd dispatch to compute pass. Okay. So I do that, but I also need to do push constant. So I can just do all of this right here. Yep, so set push constant. Let's give these real names. So what is this? This doesn't have any. Or wait, yeah, it does. Draw pass consts, I don't know. And then this is frustum consts. And this is also frustum consts because these are the same thing. It can definitely be cleaned up, but that should work. So we have frustum consts, and then it was draw pass consts. Right. So now I have this t data. So set push constant. So I do have to give it a type. So I might change this around to just get me the pointer to the push constant. That might be better. And then I can just write whatever I want into it. And the space is already allocated. Yeah, it's just like a void pointer or something. Yeah, but for the moment, I'm just going to define these here, and I can make it better later. Struct frustum consts. So just copy paste. And these I don't have to worry about memory layout or anything, I don't think. So there's that. FC. Yeah, also there should be like a const reference. Yeah. Could definitely be better. Okay, so total instance count. Yeah, near D. Okay, yeah, and this stuff I have to get. Okay, so this is a little complicated. So I have to pull this stuff from the camera. Okay. So maybe I should be doing this in the main function. Okay. And then this one, draw pass. What does this need? This needs indirect draw count. Yeah, well, that's basically just the size of the indirect draws buffer. Or is that just indirect count, or am I updating this? Indirect count. Yeah, that's just the size of the buffer. Like that's what I'm using it for. Yeah. Draw index. Yeah. So it's just the size of that buffer. So, or no, it's not necessarily the size of the buffer. It is the number of like active draws I have. Okay. So yeah, this would be a lot better if I just had like a pointer I could write to. Right. Because I can say just like get and then void pointer ds. And so really, hold on, if this is, or yeah, why am I doing it like this? Why am I doing a push constant? Doesn't make any sense. Indirect draw count. Yeah, but if I have that in a buffer, then it's in a buffer. Why did I ever, I don't know. Just some bad code, I guess. But yeah, if I have the buffer set up for that, then I should be using the buffer. Maybe I was like reading it before and I didn't realize it was a push constant, so I turned it into a buffer, but so whatever. It's a buffer now, so I don't have to worry about the push constant for that, which, is that better or worse? I'm not actually sure. Yeah, so I can just make that a buffer and just, yeah, just say indirect count, and that'll be fine. So, yeah, this is a uniform buffer. This needs to be, this is a storage buffer. Okay. So I can say read only buffer. Okay, and then there's cold draw indirect count. Okay, so in the cold draw indirect count, this is what gets passed. Yeah, in the cold draw commands, this stuff is what I need to pass to the indirect, the draw command. Anyway, read only buffer. It's really indirect commands, indirect count. Yeah, I'm like mixing cases here. It's kind of stupid. Indirect count. You went. Yeah, it should look like this. Okay. That's fine. So that should line that or layout. Set 0 binding 1, 2, 3, 4, 5, 6, and I just want to. There we go. Yeah, it might actually complain because this might have to be uppercase or something. I don't know. Yeah, the rest of that's fine. Oh yeah, I made that a buffer because I needed that for whatever cold draw under account. Yeah, that's why that's a buffer. So go back to the renderer. So yeah, when I go down here to this indirect count, draw allocators, indirect count parent buffer. Yeah, and so this will never get reallocated, so that's fine. But I do need to set indirect count properly. Yes, so that's indirect count, and then yeah, that sets it. But I need it to use cold indirect count. Yeah, so let's go GPU allocator, create buffer. Well, it just needs to be exactly like this. Yeah. And I'll have to copy the size over. Just fine. Well, I mean, the size is, yeah, whatever. Just match size. Indirect count to cold. Indirect count. Definitely a lot of things I need to fix here with, yeah, like I'm using different cases everywhere, and this is kind of weird. I mean, I guess this is fine, but yeah. Anyway, yeah. So cold indirect count, indirect bit. Because I don't actually need indirect bit here. Yeah, the rest of this is fine though. Yep. And then this thing should just get. That I should say GPU allocator get buffer cold indirect count. It's just a buffer. Yep, there we go. So there's the commands, there's the block count, there's the size. Okay. Yeah. That should work. Yeah, and so I'm putting the indirect count here. Yeah, that's still gonna work fine. And then, yeah, I'm just matching the size, and then the draw command, or the draw shader will, oh, yeah, here we go. Atomic add, cold draw, indirect count 1. Yep. So that's good. Yeah. And so now this won't even have push constants anymore. Yep. Now it's just frustum pass and reduce prefix sum, and so I just have to set frustum consts, so that's fine. I guess I will leave these as being named, so that way, like, if multiple shaders share the same push constants, I don't have to like set them for each one. But what I do want to do is just give me like a pointer. RG. Yeah, so set push constant, and this just does all this stuff. I could probably say get push constant, just return. Yes, just return this. So yeah, that's fine. I guess it doesn't really. This doesn't really need to exist. I can just make push constants public. Right, and then this is like a shared character pointer or something. Yeah, this isn't even a template. Push constants. Yeah, shared pointer of character arrays, something. Yeah. Can I just say character pointer? Does that work? No. Well, anyway, if I go into renderer now, and I just say get push constant, frustum consts, and I just say like of 0. Is that a thing? Yeah. Okay, so this is for addressing each character. Actually, no, I don't want to return the shared pointer. I just want to return the regular pointer. Yeah. Right. Get brackets not allowed here. Character pointer. There we go. That's better. Now I can just say get push constant, and now it's just a character pointer. Yeah. And so maybe what I can do, I can have like some kind of right push constant thing, or I don't know, let's just call this making this a lambda right now, but I'll eventually turn it into like a real function. Actually, yeah, don't pass anything for reference. We're gonna just take a void pointer, call this data or something, and then yeah, this needs to be a template. DST data. Can I even do? Is this even a thing? Auto right pointer something. Yeah, hold on. Let me just make this a real function. Just say yeah, void for the moment, and this is template type name t right pointer. Okay. Right, but I want this to be a little special where like I can call it again and again. So yeah, like I can return a void pointer, but oh, okay. So let me, how do I want to do this? Do I call DST a T pointer? I think so. I think I just say T pointer DST equals data. Like I can do that. Yeah, the offset alignment stuff, that's fine. And so it's actually going to return a void pointer. And so then here I'm going to say reinterpret as a character pointer DST, and then add size of t and return this. Yeah. So that should work. And then I just have to like feed it back in. And I'd like to do that automatically, but I think I need a class or something. Yeah. We can just make it a struct. Struct right, I don't know. Or maybe struct writer, so there's no conflict or anything. Yeah, and so this is just going to have a void pointer called DST. And then, yeah, and then it's just right pointer. And this just takes T data, and this is template typing T, right pointer, type specifier is required. Yeah, you're void. And you just do this basically. Except instead of return, I just say DST equals. There we go. I think that'll work. Yeah, so then I can just like write whatever data I want to this pointer over and over again. So yeah, I do like get push constant or something. And then I can say like writer. So this is a class, right? Say like writer.est, but don't I have to initialize it? Yeah. So say like, say maybe just writer right. Call this a pointer writer. Pointer writer. And to make this even easier, I can just have ptr writer void pointer dst. Yep. And you just take destination, which would be this. Right, and then I can just say writer.write. Okay. And then I can just like write a uint or write a float or whatever, and it'll just keep iterating. Okay. And it's just kind of up to you to not segfault it, which is fine. So if this is everything I've allocated for it, yeah, so I need total instance count. Well, that's going to be the size of yeah, the size here. This thing basically. Write this, and then this is instance indices. Right, and then this is all the camera stuff. Does this not work? Attempt to cast is illegal. L value cast not supported. What? It's not an L value. What? Or, oh. Or, no, that's fine. L value required as left operand of assignment. Assignment to cast is illegal. I swear I've done this like all the time. L value cast required as left operand of assignment. L value required. Oh. Yeah, but DST is an R value. Yeah, but like, why? Just give me a. Do I do something like this? DST equals this. Something stupid like this. Let's say T pointer, and then say DST equals data. Incompatible assigning from unsigned long pointer. Like that. There we go. I think that'll work. Right. So like DST. So this has. Yeah, it's at like a certain. It's at it's at like 0, right? Then I turn it into a T pointer. And then, yeah. And then I just write to it. Yeah, that should work. So I don't know, can I just replace this in here, or do I have to have the assignment? No, that works. Okay. It just didn't like that I wasn't turning into a T. Sweet. Yeah, and then reinterpret as a character pointer and add the size. That's fine. So back to this. Yeah, write or write. So write that. Yeah. Actually, what's nice about this, like, total, it's actually, yeah, I need to rerun this every time. Okay. Because it can change every frame. So I need to do that. And this thing's going to go in common because this is neat. Oh, what did I just do? Okay. Pointer writer. Yep. There we go. Yeah, so I can write it there and just do that every time. Yeah, and that'll just write to the start of it. And then here, then for the rest of these, this stuff has to go in the main function because that's where I actually have the camera. Yeah, and I can just like start at an offset of UN, so that's fine. So yeah, let's just get rid of that. Come over here, and I know I should have like set compute push constant something up here. Yeah, fill compute push constants. So it's basically this. So let's see. What do I? Right. So I have that one's done. So near D, far D, ratio, sphere factor X, Y, tang. Okay, and then XYZ campos. XYZ campos. Okay. So it's all right here. Let's just say void set frustum cam consts something. So you're going to take a camera pointer cam, and then I guess I also need to take a render graph pointer or G, and then I can just do all this stuff. And oh yeah, since this stuff doesn't change, yeah, I don't need to do this every frame. Set frustum well, I mean, just call this vars and consts, right? Because this is const. Well, I mean, they can change. What do I want to call this? Set frustum consts. Yeah, set frustum cam consts. I don't know, whatever. It's fine. And this just takes. It's gonna take all this stuff actually. graph RG. And okay, and then these will be const references. So that's VF of. Actually, I think I have these VF of V. Where? Okay, vertical FOV. Yeah, so when I create the camera, I'm doing these. Yeah, that's fine. Just do that again. Alright, so vertical FOV, aspect ratio, near clip, far clip, undergraph. And these can all be const references. Okay. And then I basically just need this stuff, but with right pointer. So let's get pointer, writer with RG, get push constant. Yeah, the render graph should already exist by the time I'm calling this, and so the push constant should already exist. The pointer for it. Get push constant. This is Frustum. I can't remember the name of this. It's a stupid name. Frustum const. Okay. Now the order of things is near, far, ratio. Yeah. So let's say writer dot write near clip. Far, yeah. Near, far, aspect ratio. And then for some reason I'm multiplying the vertical FOV by this. Oh, I'm like converting it to radians or something. Yeah, so times equals, right? So then let's just say like float VFOV, yeah, divide by 3. Yeah, I'm pretty sure this is radians equals vertical FOV times this. Yeah. And then writer right the FOV rad. Is this the right order? No, this is not the right order. Where? Hold on. Oh, I don't even write this right. I use this for this stuff. VFOV rad. VFOV rad. Okay, and then instead of tang equals, so I need to do sphere X and Y first. So okay, but then I need the tang, or tang times the aspect ratio. Okay, so then I do need to get tang. Okay. Let me just put the, yeah, I'll put them here. That's fine. Yep, so near clip, far clip ratio, sphere factor X and Y. And this is angle X. Yeah, so angle X, whatever. This is tang times aspect ratio, and this is 1 over that, and then so sphere factor X is just this. So I'm going to say writer right this thing, and then writer right this. Like this. Also make sure this is float. Yeah, 1.0 F should all be floats. Yeah. Yeah, and then write the tang. So there's probably some more room for improvement with this writer, pointer writer thing, because like I don't actually know what this is writing here, like which thing. Right, but it's good enough for now. Let make this a little easier so I don't have to like throw these definitions everywhere. I mean, I still have it up here just to look at it, but anyway, right. And then so now set cam frustum const. So, oh, right. So writer, so then I need to do plus size of uint or something. Yeah, so it's not great. Right, yeah. Yeah, that's not great. Because now I have to do like the size of all this stuff. So, yeah. Well, no. I don't have to because I can get what this pointer destination is. Yeah. It's just not a great solution. Like, I can have this defined and then use offset of, but like, then why don't I just leave it defined and use the struct anyway? That's less complex. Right, I can like return this or something and then get the destination pointer or something like that. That works. It's just not a great solution. Yeah, like I could take a writer in here or something. I guess it kind of works. It's just not great. Yeah, and then also I have to like go backwards when I want to do this again every frame. Yeah, I mean, so like I know these are 4 bytes each, so I can just add the offset. I guess that's the way to do it for now. It's kind of stupid, but it'll work. So maybe doing it the other way is better. I don't know. How many flits do I have? 1, 2, 3, 4, 5, 6. Yeah, so that'll work. It's just kind of stupid. Anyway, writer dot write xyz campos, and that's this stuff here. So x cam rotation, yeah, xyz, y, z, writer dot write cam position. There we go. So that'll work. And then I don't need the struct. Who needs structs when you have void pointers? So camera cam, yeah. And then down here, yeah, aspect ratio, okay. So like whenever I update the projection matrix on the camera, it's basically when I want to call, what is it? I don't remember what I call this function. Set frustum const, set frustum cam consts. Okay. So set frustum const. Yeah. So this is vertical FOV, aspect ratio, near, far, and render graph. No, just have RG in here somewhere. Or I might say like renderer, render graph. Yeah. Here we go. And then this also needs to happen down here. Yep. And then when I do camera update transform, then I want to say set frustum cam consts cam, and then renderer RG. Why is this mad? Camera pointer Yeah, I guess it can just be a const reference then. It's fine. Whatever. So that should work. So that should upload uh, all the push constants. Here we go. So there's push constants. Yes, it's all set up, right? I just have to actually write the push constant values to this value here. And then every frame it'll handle doing the push constants for me. So that's great. Okay. Now specialization, and yeah, maybe it'd be good if I could set something up to like validate that I have stuff in there, whatever. Specialization constants, synchronization, and dispatch to compute pass. Okay. Let's look at specialization constants. So I know I have some code. Yep, this. So this was like the old code. So this is definitely not good. Or I mean, maybe it's fine. Yeah, unique constant counts only add unique entries. Sometimes constant IDs are repeated. For example, this uses the local size. Okay, sure. Spec entries. Okay, well, I don't need to have spec constants. I just need spec entries dot size is greater than 0. Yeah, because I guess this is what the shader actually holds. And then, yeah, set specialization info, map entry count, map entries. Yeah. Why did I ever? I don't know. Then allocates. Yeah, no, that doesn't matter. So get rid of that. Yeah. And then spec entries. And if spec entries dot size is greater than 0, this should be stage info. This is specialization. Where's this coming from? I don't know. Oh, I just need to like define this or something. Okay. So it should be the total size of the spec const by the end of the loop. Okay. Sure. Seems a little. Oh yeah, data size. Yeah. I see what I'm doing. Yeah. I need spec entries and spec info. So I can go in here. And what is this? Pushback entry. This is specialization map entry. So standard vector of this called spec entries. Okay, now I just need spec info. So if I look at the other shader, no, where's the other shader? Is this spec info? Is this just like why is this not in here? This is terrible. Yeah, what? How is that? I know I'm doing reflection in here. Yeah. Oh, right, because I did underscore. Yeah, I'm pretty sure like the shader just owns this or something. Shader spec info. Yeah, there it is right there. So let's go in here and it's just pk specialization info spec info. Do I need like a structure type? Spec, no. Okay. Yeah, right, there's not. Spec info dot. Yeah. Okay, and then these just need to get prefixed with underscore. There we go. Hey. What's up? I'm working on my game engine. Currently, I'm trying to get compute shaders working. And so I'm actually rewriting my engine because the old code didn't support like dynamically adding or moving objects, and it was a whole lot of work to get that working. so I'm kind of rewriting everything. Um, yeah. And so currently, so the old engine does work with compute shaders, and I think this is like the last thing I need before I can get rid of all the old code. Making a game, yeah, eventually we'll get there to actually making a game. Right now I'm just making a game engine. So let me see if I can show. This might not run. I might just like go to an old commit. Let me see. I can show you what I have so far. Yeah, I think if I want this to run, I think I just need to comment this stuff out. Yeah, but that, no, that's probably fine. Let me just see what this does. Oh, okay, yeah, it crashed. Get rid of this stuff. And then, yeah, I think I also need to get rid of some of this. Yeah, let me just go back to an older commit. That'll be easier to show you what I'm doing. How's the game look like? Currently, it's not much. Let's get add all, get stash, get. Oh, it'll kind of be like a first-person space game. So I don't know, like No Man's Sky or something like that. I don't have like shipbuilding and stuff like that. And it's all open source as well. Yeah, I want to do like some kind of like PvE survival space game thing, or kind of like Elite Dangerous. And I'll probably have like PvP stuff in there, like you could run a server and things like that. Anyway, yeah, so stash all that. So then I think I can just run this here, and this might work. Shirt is too pretty. Oh, yeah. I think this was like $10 on Amazon or something. Um, yeah, it was just like a cheap Hawaiian shirt from Amazon. Um, anyway, yeah, this is what I have so far. Um, so I'm drawing out here. This is just like a million of these simple box models I have. I'm just like testing how fast I can make objects. So in here I've got some animations going, testing that. This has got like complex geometry, and so I'm like making sure all that works. These ducts, so I couldn't find a good model for a light bulb. So these ducts are light bulbs technically, and like the light doesn't get blocked from them or anything. And then this is like a chessboard model. This is another like more complicated model. Yeah. Yeah, so just like a few little test models. Yep. Anyway, git stash apply. There we go. So, yeah, so I'm trying to get these computers so you make a full space. Yeah, it'll be like it'll be procedurally generated space game kind of thing. So I won't just like make all the maps. I'll have it generate them for me. Maybe I'll have some specific stuff in there, but a lot of it will be procedurally generated. And see if I can get this working. So specialization, constant, synchronization, and add dispatch. Okay, let me add the dispatch. And so what these compute shaders, what this is for is I can tell it to not draw any objects that like you can't see on the screen. So like if I, yeah, I think I can still run this. Maybe I can, yeah. So like if I look over here, then I don't need to be drawing anything. But if I'm looking here, then yeah, I do need to draw stuff. And so that just helps increase the frame rate. And so I think the Vulkan driver for Linux, it does actually have some of this built in. So you see my frame rate right now is about 144 FPS, and then I look away and it's like 500. So it already has some of that built in, but this this will be more effective, and it'll work everywhere and not just like on specifically this one Linux driver. Yeah. So I need to do add dispatch. And if I look in shader, or where is it? Pipeline. Trying to look at my old code right now to see what I was doing before. Is it here? No, I don't think so. Oh, yeah. So here's specialization constants. Yeah, I guess I'll do these then. So this is just options. Okay, so this is for setting the data for it. Okay, I see. Oh, yeah, and here's dispatch. Okay. So group count X, Y, Z. Okay, so I can kind of do these together. And then where's dispatch? Is it in this file? Should be in here. Yeah, there we go. Yeah, so vkstd dispatch. Okay, so it's just group count X, Y, Z. That's fine. So, and here, this is where I should be getting the group counts. Yes, get group count, then 1, 1. Oh, yeah. I try to talk through what I'm doing to make it make sense, but what I'm doing right now might be a little complicated. Like earlier, I was getting animations working. That was probably a better time to watch for learning, but I'll try to explain what I'm doing. Yeah, and then this one. Yeah, so right now like I said, I'm trying to get the compute shaders working so I can do frustum culling on the GPU. And yeah, I'm just basically going to copy paste a bunch of stuff from the my old engine. So this is like how many GPU threads I want to run the culling on. That's what I'm copying right now. I'll put it. I guess it would have to go here. Yeah, so I want like vk cmd dispatch. Right now, this is most of what I do, just because it's just what I'm having the most fun with right now. And I only started streaming like a week and a half ago, and so I might like start playing games on stream at some point. But for right now, this is all I'm doing. And then I do like play some games with some of my friends sometimes, but that's all off stream. Okay. Yes, okay, group count. Yeah, that's fine. So yeah, I need to add a node. Add dynamic node. Yeah, probably. Yeah, I like playing with my friends. Do you stream daily at the same time? I have my schedule down somewhere. I try to follow it. I'm usually within like 30 minutes of that schedule. So right now I'm only streaming on like weekends and Monday afternoon because I do other stuff during the weekday. And then I also work most of the day anyway. On weekdays. So yeah, usually I'm streaming Friday, Saturday, Sunday, and then like Monday afternoon. But if you look in the stream schedule, it'll tell you everything. But right now I'll probably be on for another like 2 hours or so, and then I might take like an hour break, and then I'll be on for like another 3 hours. I usually do about 3 hours at a time, then like a 2 hour break. But I think I'm like off by like an hour or an hour and a half today or something. But I'll be on for like at least the next 2 hours because that'll be 3 hours of this like session. So yeah, add dynamic node. this in here. Then I can say, say command buffer, and then I can pass in the group counts, right? Because this just takes, yeah. Okay, but this can only take that. Yeah, so then I need to run get group count here. So this basically goes right here, or yeah. Okay. So I have that, and then compute push constants, total instance count, device max work group invocations. Okay. So this should be device. So what I did here, this is setting it up. I'm just setting up to actually run a command. Advice on learning coding quickly. Get stressed out just think about it. I know there's where is it? Build your own. Yeah, here we go. I don't remember how beginner friendly some of these are, but this is just this is a big list of tutorials about all kinds of different little things you can build. So some of these, I think a lot of these are maybe more than, these are like a little more advanced, but some of these should be pretty simple. Yeah, like this Python, how to build a Reddit bot, something like that is probably pretty simple. Yeah, database is probably a little complicated. Yeah, just like doing little like website things. Yeah, so there's some simple stuff in here. Some of it's a little more complicated though. But for the most part, like I learned just kind of building random things, and like even with this, I'm learning a lot. Yeah, well, I mean, going from like C++ to Python is not really all that difficult. It's kind of like once you know like how programming works, then you can like kind of jump between different languages. It's more like different accents rather than like different languages, if you think about it like that. Yeah, but I learned by just like building random little things and learning as I go along. It's the same way I learned how to do all this graphics programming stuff. Just kind of making it up as I go along. Yeah. And so I'm sure even outside of that website, like if you're kind of just starting out, you can find a whole lot of tutorials on YouTube and other places just for finding things to yeah, just find like small little things to do, and then you'll kind of, once you kind of get how it works, then you can mess around with it and like start changing code or changing it to how you would like it. And then a lot of times you'll break things, and then you just go and fix it, and then you learn a lot from that, from like breaking it and then fixing it. Consistency is a success. Yeah, kind of. So total instance count. So that comes from this right here. And then max compute workgroup invocations. Okay. I guess that's like a device property or something. Max compute workgroup invocations. Okay, am I filling this out? I am. Great. I just have to return it. Okay. Something stream is amazing. Oh, thanks. I'm not sure how entertaining this is right now, because this is, again, like I said, it's a little more complicated than probably that I can like easily explain. Yeah, okay, and then get group count. Is that in common? Yeah, it's right here. Actually, I might already have this up here. Get. No, I don't. Okay. Put it here. Very back. Yeah. Yeah, that's all right. Yeah, so add a node, and this is for actually dispatching it. Yeah, and this will dispatch a current buffer. Yeah, and so ideally I'd put this into compute pass, but the problem is I need this to run every time. So yeah, I could do like dependencies and stuff. I could say, basically I need like a function that returns an integer. Yeah, or a function that returns 3 integers. I'll leave it like this for now. Put this into compute pass. Yeah. Let's see, is that how I was doing it in the old one? Yep. Okay, and then this is a group count of draw count, which is indirect draw size. Okay. Yeah, I knew it was something a little different. So that's going to be the draws buffer. Indirect commands, yeah. Indirect command size, okay. So that should run all of it. So now I have synchronization and specialization constants. So I was kind of doing specialization constants already. Yeah, so I filled them out here. And then I think, yeah, so I need to set the data itself, because I think it's a spec info, yeah, p data. So I need to set the data, and then I also need to set it, to load somewhere. Spec info, where else am I using this? Info, not in there. Okay, yeah, so I have p data here, and then, but how am I uploading this to the GPU? Yeah, I still need to tell the GPU to use this. So that's got to be in the pipeline, I would think. Spec info, no. Let me see everywhere I'm using it. Yeah, like that. So, yeah, I don't think anyone's here right now, but okay. But anyway, yeah, right now I'm trying to get the, trying to upload some of the data that the shader needs to run into the GPU. And I'm trying to see how I was doing it on the old engine. Okay, yeah, so stage info, specialization info, that's how I'm doing it. Line 241 in shader. Yeah. So shader line 241. Oh, yeah, so I'm setting it here, and this is the stage info. Yeah, okay, that makes sense. And so I'm doing it in here. Yeah, stage info, specialization info. Okay, so I just need to set the actual data for it. And then, so if I look in the shader, yeah, so this one special, are these all the same local size, group size, local size, group size? And this is just local size, okay. Yes, okay. So, yeah, to set the data pointer, and so I'd have to set it on the shader before I call dispatch. Yeah, and I need to set it, or when do I actually upload it? Let's see. Right, it's when it compiles the shader. Right. Right, that's why I'm passing it in here. Yes, that makes sense. So, yeah, shader options, push constant data equals draw count. Yeah, okay. So, then when I actually compile the shader, and that happens, or no, not when I compile the shader, but when I create the pipeline. Yeah. Right, so graphics pass, create pipeline. Yeah, shader stages. Okay, so I need to set it before I create the pipeline. Okay. And that's happening, actually, yeah, it's happening here, right? Because then I say like end rendering or something, and then I actually compile it there, I think. Yeah. Does that compile it? Render graph, end rendering, add node. It just adds a node. Right, when do I actually... Okay, so I create the pipeline in line. Okay. Yeah. So I do create compute pipelines when I call this, and that gets called from doing compute pass. Okay. So then I'm going to have to pass in specialization constants here or something. Right. So I would have to say, yes, there's load shaders. So shader stages. Yeah. So then if I said like pipeline info dot stage dot specialization info, or shouldn't I be able to... Oh, it's const. Oh. Is that because... No, that's not const. Shader stages at 0 dot... No. What? Protected, yeah. I'll get this to work. Because in the shader, so I have specialization info here. Yeah, so I just need to set spec info.pdata. That's all I need to do. So, yeah, when I'm compiling the shader, I need to, or I mean, it's not really when I'm compiling it. It's just at some point before I actually create it in the pipeline. Yeah, sometime before this call, I need to look at the shader and load the specialization constant. So if I say, or the data pointer, say for shader in shaders, so shader okay. Right, but I guess I don't really need to set it there. So stage, shader create info stage, and this is shader stages. Right, and that got copied from it. But then why can't I set, if that's shader stage create info, why can't I set it here, right? Because this is the same thing. Yeah, shader stage create info, yep. So this one's set on the shader, this will set on the pipeline, which is fine. So I should be able to say pipeline info dot stage dot, or p specialization info. Right, but that's const for some reason. Why is that const? So I can't set p data equals this. Does that not work? Cannot assign to non-static data member with const. Okay. Go to implementation or go to definition. Does that work? Okay, so it is marked as const. Do nothing. Yeah, so I can't set it here. So I need to set it in the shader. Or, I mean, I can set it here like this, I guess, but... Yeah, I can just add it as something in shader, like this. And up here, I can say, what would this be? I guess it's just a pointer. I go spec info dot p data. Yeah, it's just a void pointer. Okay. So if I say void pointer specialization data, and do it like that. There we go. So that'll set it there. Yeah, that's fine. And that can just have a default value of a null pointer, and that won't be a problem. Oh, I didn't mean to close it. Hit the wrong button. Yeah. Oh, you're back. Yeah, I just accidentally closed this. Okay, where was I? Source is here, here. Okay, yeah, so specialization data. And so I can pass that, and so I can default that to a null pointer, because if it's null, or actually I want to look up the specification for it. So I'm looking up how to actually handle this in Vulkan. Yeah, you can join the Discord server. That's fine. The link is somewhere below. Yeah, you should have found it. Something look at Vulkan. Yeah, somewhere in here is what I'm looking for. Can I just see the whole thing? Yeah, here we go. So I'm looking for specialization constants. Right, so void pointer p data. P data is the actual constant value to specialize with. If data size is not 0, p data must be a val pointer to an array of data size bytes. Okay, yeah. And so if I don't have any constants, then this is just going to be 0, and so it won't even read this, and it doesn't matter. Which can be null to indicate no specialization constants. Yeah, so I think it should be fine for it to be 0. Okay. Then, oh, just join. Yeah, thanks. So specialization data shader. So then I'm going to need to change the pipeline code, because now when I'm, I just need to change load shaders. Okay. Yeah, so shader paths, and then I guess this can take a vector of void pointers and call this specialization data. And then for shader path and shader paths, so I don't want to do it like that. I want to iterate over it this way. And then shader paths dot size. Shaders. Yeah, that's fine. Shaders push back. And then instead of shader paths of I. And then let's say shaders of, and then, yeah, specialization data of I. There we go. Yeah, so I had to change this loop around so that I could actually pass data like this. Now I need to change this constructor in here. Yeah, here it is. There we go. Yeah, and ideally, well, okay, this can be a const reference. Am I able to default this to be like null pointer or something? No, I can't. Okay. That's fine. So pipeline load shaders. Been busy past few days working on projects. But you finished them. What have you been working on? Doing art? Yeah, specialization data. That gets passed there. And that'll get passed to the shader. Okay. Yeah, so the load shaders. Yes. So now I need the specialization data here. Okay. And so this should take two of them. It should say vert spec data and frag spec data. And yes, it could be better, but this will work for now. Compute spec data. All right, so now throughout here, I need to add this pointer compute spec data. Yeah, and I can actually just call that null, default that to null pointer, so that'll work fine. Yeah. Oh, but then I have two default arguments here. Making a banner overlay for your client, like a coding theme. Oh, yeah, that's cool. Yeah, these don't have to go at the end. That's fine. Full pointer for expect data or for expect data. Pointer for rag spec data. And then same thing in here. So, and so what all this I'm trying to do now, this is the specialization constants. And what this is for is if in your shader you want to like you want to pass in some data at compile time. So like let's say you have like two paths in your shader. One of them is like, I don't know, fast or slow, but maybe the slow one works on all the hardware or something, and the fast one's work on all the hardware. Well, then what you can do is you can say is in this specialization data, you can tell it to you want to say, oh, I want to use the fast code this time, or the slow code this time, and it's it'll compile a shader specifically for just having that like fast or slow code, and things like that. And what I'm using it for is actually telling it like I'm using it to tell my compute shader some information about the GPU it's running on, and that lets it know. It needs to know like how many threads are currently running on the GPU or can run on the GPU in order to figure out which in order to figure out some of the compute culling stuff. So that's what I'm specifically using it for. But yeah, these they're just like compile time constants if you've done anything with that. Like kind of like if you do like hashtag define or like if def, if not define, that sort of thing. This is kind of the same thing, but for shaders and not like C++. So yeah, create, okay. And then I'm gonna have to pass these in. Yeah, then I also have this, which can be null. So that's also annoying. Yeah, so I'll do it. Yeah, it'll have to come first. So, or, so if I actually look at, yeah, I'm gonna want to pass this into the create function, right? I can't just figure this out. Can't figure out what data put into it from here. Okay. So this one should be a little easier to do. So I can compute spec data. Compute spec data. Okay, too few arguments. Expected single. Yeah, or too many. I thought I updated that. Oh, compute create. Compute spec data. There we go. Oh, I need to update this one as well. I guess make them non-optional, maybe. Or yeah. Or yeah, because it's maybe I do want to put it at the end because then I can make it optional. Art stuff, grow channel very fast. Yeah, I could use some art or something, but and I'm not really looking to like pay for any art right now. But yeah, like I don't have a banner or anything. My logo is just like a screenshot from my game engine. I can definitely get around to doing more art. Yeah. So void pointer compute spec data. Yeah, I can do that here. And yeah, I can do the same thing there. Spec data. I do. Amazing. Oh, thanks. Yeah, I've only been streaming for, I don't know, a week and a half. I'm up to 13 followers, minus like 2 or 3 just for my friends. Yeah, and I think I have like a few, like 150 views on YouTube or something. A few, I don't know if I have any YouTube subscribers, but yeah, I think I'm doing okay for starting like a week and a half ago. Where am I from? United States. Specifically, I'm living in Texas right now. Share your stream with your 10 friends. Oh, thanks. Yep. So go up here. I want to get these, yeah, this stuff here. So yeah, too few arguments. So I need to say for expect data, enter the same thing up here. Just that, and then yeah, okay. So let's create. So then I also need this stuff here. Okay, and then also right there. There we go. And then just copy this into the headers. There we go. I think that's everything. Yep. Okay, that all looks good. So now, yeah, now I can pass that in. So I need to go to here. Yeah, and so this, I need to pass in specialization constants. And so I can pass it in here into compute pass and into graphics pass. Good. Graphics pass, index buffer, vertex buffer. Okay, and I'll put these at the end. So I'll say void pointer, or inspect data. There's no void pointer. For expect data is null. And then compute pass. Compute spec data is null. Half is complete. Yeah, I've got a lot of it done. I'm just, all this is like really boring boilerplate stuff right now. So it's, yeah, I'm just trying to like pass these variables around everywhere, but I'm definitely making progress. Right, and then I can pass this in here, and here. And then you're from Florida. Okay. Yeah, no, one of my friends is in Florida. Okay, that should be good. And then pass it in here. And this goes here. And then it goes here. Did put this in the right spot here. No, I think it goes before this. There we go. Okay. So that should be all the boilerplate out of the way. Now I need to actually set this stuff up. So compute pass. So I look at the shader. So this first one, this needs the local size and then the subgroup size. Okay. And so that's, yeah, it's probably just like that same group count code and then max invocations. Let's go to, or yes, this is an old one. In here, yeah. So local size is this. Okay, I'll just copy this. That's everything I need. Pipeline renderer. So local size X is device max compute work group indications. Love to, yeah. You can send me some of my work. I'll definitely take a look at it. So, or send me some of your work. I'll take a look at it. Yeah, so this is max compute work group invocations. Okay, and then I think I'm actually, I was putting these somewhere else. I'm not sure. Yeah, I'm using this here, but that's a little different. And so when I make this compute pass, I need to pass both of these in. And so I actually have to, just for the moment, I can do it like this. Compute, or say, custom spec data. And this is, what would this be? Yeah, local size X. Yeah, these are UNs, so UNT local size X. Actually, just don't expect data. then subgroup size, and just call this spec data. That's fine, and then I can pass this in here. There we go. And there is a better way for me to handle this stuff so I don't have to like define this struct here, but don't want to do that right now. I can get it working later. So I'm pretty sure that's all I needed. Go down here. Yeah, set local size, set subgroup size. Okay, push constant data draw count. Yeah, I'm already handling that. Okay, group count. Yeah, shader options, shader options, shader options. Okay. I think that'll work. Oh yeah, and then I still need synchronization. Okay. A lot of steps. So basically I need to do this memory barrier thing here. Yeah. Yeah, so pipeline barrier, command buffer, dependency info. So let me look at how I'm doing this over here. Yeah, I forgot there's another step I had to do before this is all ready. Yeah, but I just want to do it like how this works. Same kind of thing. So yeah, and I guess I want to return a shared pointer, or no, I just want to run add node. Yeah. So, so it's actually rendered graph memory barrier. Yeah, I guess that's fine for now. And so it's not going to return anything. It's kind of going to do this sort of thing. Right, so get rid of this. So I've got this memory barrier, and then the dependency info, and then this command. So I want to say auto barrier equals make shared PK memory barrier to this, and then set the structure type s type equals this. So what I'm setting up now is, so on the GPU everything runs kind of asynchronously, or like none of the ordering is guaranteed. So what I'm setting up now is our memory barriers, and that lets me tell it, hey, wait until all the previous commands have finished before doing the next stuff, because like my different compute stages depend on each other, and then so does the graphics stage, depends on all the compute stages being done. So this just lets me define the dependencies, and so right now I'm setting up the a function for this to be able to easily add these to my render graph. So, and this is dependency info, and this is vk dependency info, and then set the structure type. What's this? There we go. And then memory barriers is this memory barrier dot get. There we go. So that's the same thing there. And now here I need to add memory barrier and what was that? I don't know. Yeah. Oh, did you want me to pull up the art right now? Is that what you were asking? asking? So, or were you asking about what I'm doing? Have a look on Discord. Okay. Yeah. Sure, I can pull that up really quick. Okay, let me. Yeah, it should show up on the other window. Oh, hold on. One message. Show message. Okay. Yeah, I've got Discord pulled up on the other monitor. If you send something, I'll take a look at it. I can pull it up on the main monitor. Yeah, I think you should be able to send stuff. Yeah, if you can't, then let me know. Because I don't see anything. Or did you send me a private message? No. Message requests. Oh, there we go. Okay, yeah, I can pull this stuff up. Or actually, I'm not sure how to like. I guess I just pull these up one at a time. Can I do? Yeah, open in browser. I just don't want to show my whole Discord screen. That's all. Um, you know what? I can do it. I can kind of do it like this. There we go. I'm only sharing a part of it now. Um, oh, and then I need to fix the window. Yeah, I can definitely. I need to figure out how to do this correctly later. I'll do that after the stream. Because I'm sure people send me stuff all the time. Yeah, portfolio you made, give you a review. Yeah. Let me look at some of this. Okay, so this is like starting soon intermission. Oh, so these are just like little templates. So this would be like a banner and stuff like that. Yeah, this looks cool. Yeah, same sort of thing. These are, I guess this is like a icon or logo or something. Yeah, yeah, that's cool. Man, I haven't seen that show in forever. Um, yeah, and you did all this yourself? Yeah, Behance portfolio. Okay, never used Behance before. Let me see if this is something I can open up. Oh, this is some Adobe thing. Okay. Doing this for 5 years. Oh, yeah, yeah. These were, yeah, it was like pretty good. Uh, yeah, like the art was pretty good, just overall. Let's see, streamer pack, business logo, gaming logo. Yeah, so like a gaming logo or something. Okay, so this is like all the stuff you've done. Yeah, like this stuff's pretty cool. Um, Eventually, I'll want to get some art. Um, I just I'm not interested right now. Streamer pack. Okay, yeah. And so this is like the logo, all the little panels and stuff. Yeah, and all the screens. Okay. Yeah, this is pretty good. Banners. Yeah. Oh, yeah. Yeah. Yeah, the stuff's pretty cool. Eventually, I'll want to get some art. I'm just not interested like today. But yeah, all this looks pretty good too. Yep. Um, here. Yeah, not color attachment or anything. Yeah, that's fine. What is this? This is the right. This is the update function. I don't have any updates. I don't think. No. Yeah, this doesn't have any updates. So it's actually void update. And then it's not begin rendering. It's pipeline barrier 2. And then just dependency info, I think. Right? Is that how this works? I don't remember. Check last night. Yeah. Yeah, I'm not interested in paying for any art right now. That's kind of what it comes down to. Maybe in the future, once I'm like once I'm like more into streaming, because I've only been doing this for like a week and a half. Uh, I want to keep up with it, but I don't know if I will or not. And so yeah, for now, I'm not interested. Sorry. Um, but yeah, if later on I want something, I'll send you a message and see if we can work something out. Check it. Yeah, yeah, Um, I see your messages. Um, you know if I am interested in something later on. There you go. Yep. So is this how this is supposed to work, or drops paragraph builder? Where was it? Where's that code I copied this from? Oh yeah, it's up here in render graph. Yeah. Yeah, so I do pass info.get. Okay, so I just give it, so yeah, I need to give it the actual data itself. Okay, that makes sense. Um, renderer dependency info.get. There we go. So that should handle memory barriers, and then this actually needs to go into render graph down here. Barrier. There we go. Okay. Now what? So let me just copy over the synchronization stuff from the old one. Yeah, so I have this one. Yeah, I just copy the whole thing is probably fine. Yeah, that's all the memory barriers. And so let me put this one, should go here. Memory barrier. Yep. And get rid of that. Or, hold on. Did I have a comment I got rid of? No, okay. Let me do it like this. Replace all this with like that. There we go. And then, okay, so this one goes above here, and then the shader, yeah, and then wait for the shader to finish. Yeah, and then wait until this one to finish, and then make sure that stuff finished. Yeah, or no. This goes right here. There we go. Get rid of these, and I still need to set buffer. Yeah. Barrier until it's been cleared. Clear that out. And then barrier here. Yeah, get rid of that. And then wait for culling to complete. There we go. Now I just need to zero out the buffer. So set buffer, call drawn direct count 0. Is that? Yeah, that makes sense. So I need, should be set buffer in here, fill buffer, device offset size, value. Yeah. Okay. Yeah, get buffer, VK buffer, offset size value. Then how was I doing set buffer? I guess I was just wrapping around fill buffer. So go back to this. Barrier, and then here's fill buffer. Right, so buffer name, offset size, value. Okay, yeah, and this just basically goes straight to fill buffer. That makes sense. Yeah. Well, is there? Let's look up the Vulkan spec. Is there set buffer? No, there is fill buffer. Filling buffers. Size, number of bytes to fill, VK whole size. Okay, so it can just be 0 and then VK whole size. And then for data word written repeatedly to fill size bytes of data. Okay. So I'm going to just ignore that for a second. And I'm just going to put this directly into here just to get this working. And so I need another node. Add node. The function is fill buffer, I think. And then arguments are, let me see, how does this work again? I never remember. Yeah, so it's just, okay. So it looks like this. So add node. So this is dependencies. This has no dependencies. Update function. Okay, but if it doesn't have an update function, does this work? Right, so I can just have f and arguments. Better solution for non-struct. Graph.back.update. Set operation. Oh yeah, that's dynamic node. Right, this is just add node. Okay, just f args. Okay, that'll work for me. Or no, it won't. I need to run this. No, the buffer should never change, so that's fine. Yeah, so I should be able to go here and then offset 0 size VK whole size value 0. Okay, that should work. And then get buffer. This is cold draw indirect count. I think that's right. Look up here. Cold instance count, cold called indirect count. Oh yeah, it's just called indirect count. There we go. Called indirect count, and then why can I not do get buffer? Oh yeah, because GPU allocator, not memory manager. There we go. And then is this not VK buffer? Is this just buffer? Okay, that should probably be VK buffer. But anyway, okay. So I think that's everything. Finally. Let's see if this even compiles. Okay, so that compiled. This might crash my GPU or something when I run it. I don't think so, but if it does crash and like my stream crashed or something, I'll be back in like a minute or two. Just have to restart my computer. But I should be able to recover even if I like did something horrible. So anyway, let's see if this actually runs. Okay, well, immediately crashed. Which I guess is better than like crashing my GPU entirely. So invalid layout object. If layout is not null. Yeah, couldn't find object. Okay, I think, and then failed to open cached shader. Okay. Oh, because you know what? I think it failed to compile. So that's a problem. Okay, so there's two different problems. Yeah. Cache shaders. Cache JSON. Let me just get rid of this entry. So that's a problem. This might fix it. Okay, there we go. So translation has no field in structure object. So actually, before fixing the shader, I want to fix the problem here. So this is telling me failed to open cached shader. And so what that is I'm caching the shader compilation, or caching going from like GLSL to SpearV. I don't know if you know what I'm talking about. But I'm caching one part of the shader compilation. But my caching code doesn't handle a case when the compilation fails. It thinks it thinks the file exists, but it actually doesn't. So that's why I'm getting this error. And so I need to fix that in here first, and then I can worry about actually getting it to compile. So yeah, compiler cache. So yeah, what actually happened was the compilation failed. Yeah, so I guess, yeah, if write buffer cache path. Okay. Yeah, so two compilation errors, no code generated. Yeah, and I'm just throwing the error. Shader linking. Two compilation errors. Okay, shader parsing failed. Okay. So it failed here. Result, if not result, if not result, if not result. So when this fails, I need to do something to actually tell the compiler cache, hey, it didn't actually get compiled. So, yeah, so I'm doing like a write cache here. Or maybe the other way of doing this is when I fail to open the file, yeah, instead of saying fail to read file, I can say warning. Yeah, this is the simpler way of doing this. I can just warn, and then, yeah, warning, fail to read file. And then I can tell it to, I can tell it that like the file isn't cached. So I need to, yeah, what would I remove it from here, or right? Because if it can't open the file, right? And like I'm trying to look at the file data, and none of that's going to work if it can't open the file. So, yeah, failed to open cached shader. Or wait. Oh, okay, it failed down here. Okay. So let me actually do it. Yeah, let me leave that alone. Yeah, leave that there. Yeah, but here if I go fail to open cached shader, then yeah, if compiler, if it is cached, then do that. Otherwise, compile. So yeah, stage is get stage. Yeah, then let me actually just say compile here, and then do the warning here. I think that'll work. Yeah. So that should work. It should at least try to compile it, and it'll give me the error again. So yeah, failed to open cache shader, and then it tried to actually compile it. So that's good. And then the compilation failed, translation, no field in structure object. So if I go here and I go to 80, so object has no translation, right. So instead of, so before how this worked is this instance data, it had the, it had like vec3 translation, vec4 rotation, and then the scale, right? Individual like that. But now I have it just directly in this model matrix. And so now I just need to get it out of the model matrix. And so yeah, this takes a vec3. And so I'm pretty sure, and actually instance data object. Yeah, this shouldn't be called yeah, let me rename this. This should be called instances. And this should be called instance. Yeah, just do it here. Instance.translation. Okay. And now I need to pull the translation out of the model matrix. And if you look at how a model matrix works, can I pull this up really quick? Yeah. Let me see. Is there a good way to show this? Yeah. So how the where's like a good example? Yeah. Okay. So here, translation matrices, right? And so the X, Y, and Z coordinates are just the last elements. They're like the first three elements of the last column of the matrix. So I just need to look at, I just need to get the first three elements from the last column. And so that's a map 4. And so I can just say instance dot model matrix, right? It has an underscore, I think. Yeah, underscore model matrix. And I want to get the 3 column and it's 0 index. So yeah, third column. And then I want to get the XYZ components. So that's like the first, I think I gotta say like RGB, but XYZ works. So I think that should work. Let's see. Okay, there we go. So now you tell me creating buffers in descriptor update is unsupported. So what this means is I forgot to create a buffer somewhere. Right, yeah, because this has like these prefix sum, partial sums, active lanes buffers, and I need to go ahead and create these on the GPU before I run this. Yeah, and actually, I wish this arrow was a little better. It should tell me which buffer it failed to create. So yeah, let me do this, and let me call this yeah, just descriptor name. There we go. Yeah. So prefix sum is the problem. And that was a few more. So let me just, for the moment, there's better ways for me to do this, but if I just want to get this to work, I can go in here, say create buffer, storage buffer, prefix sum. And I need prefix sum, and then I need partial sums, and then active lanes. Yeah. Yeah, prefix sum, partial sums, and active lanes. So prefix sum, partial sums, and then active lanes. And then also, I'm pretty sure, so this create buffer, it doesn't actually allocate the buffer yet, I think. Right, can I call realloc on this? Yeah, I can call realloc on this, but yeah, that's fine. Yeah, I'll do this later. Okay, so there's all those buffers. They should exist once I put stuff down here. So I want these to have a certain size, and they need to be the size of instance indices. So this code down here, this is something I threw together quickly to resize buffers. And so I need these buffers to have enough space to store all of the instance data and all that. And so this should be good enough. Now this is like way overkill on the size, so I'm wasting a lot of VRAM here, but it's not a big deal for the moment. So this should work. Maybe. It might still have a problem. Okay, this is a different problem. So, cannot bind compute pipeline to graphics pipeline bind point. If pipeline bind point is compute, pipeline must be a compute pipeline. Okay. Invalid issues, call inside random pass. Yeah. Okay, CMD bind pipeline. Object 1 handle. I could name the pipelines. That'd be good. There should be like, okay, there's pipeline layout. Pipeline name. After I create the, no, I am doing set debug name, okay, but I'm not doing it down here. Okay, so it's definitely the compute pipeline that is the problem. Yeah, but I want to set that debug name. So now this should tell me which pipeline is actually failing to run. Pipeline. No, it's still not telling me. That's weird. Oh, yeah, here it is. Call first unpassed. Yeah, and this is the first one. So that makes sense. Cannot bind pipeline of type to graphics pipeline bind point. If pipeline bind points is compute. Right, and this is a problem with bind pipeline. Oh, right. Pipeline bind point compute. There we go. Is there a better way to handle that? No, not really. Okay, that's fine. Try this again. Okay, a whole bunch of other errors. Buffer is no handle. Invalid issues call inside an active render pass. A lot of errors. Okay. See, I want to go ahead and just commit what I have because I have a lot of stuff. Let's just call this failing compute pipelines and specialization constants. Yeah, usually I like not having giant commits like this, but it's just kind of how it worked out. Like I definitely could have put specialization constants in another commit, but that's fine. I'll just have this giant commit. Because having smaller commits makes it easier to like go back and fix things. Like if I want to know exactly when I added an error, it's a lot better to have smaller commits. Anyway, so this is failing. invalid to issue this inside an active render pass. Yeah, dispatch. And then pipeline barrier. Dependency info cannot be called inside dynamic rendering instance. Yeah, so maybe I like forgot to stop rendering or something. End rendering. What's this? Source stage mask. Compute shader bit is restricted to frame buffer. What? If is called, yeah, within a render pass. Within a render pass, this is all like the same error. Outside a render pass, render pass, render pass, render pass. I know there was other errors. Render pass, render pass. Render pass, okay. And then I got this problem. Buffer is null handle. And then, yeah, invalid buffer object. Okay. So there's two problems here. One of them, I'm trying to fill a buffer that doesn't exist. And the other one is, I think I forgot to stop the graphics rendering at some point. So like the GPU thought it was still in like graphics mode or something and not like compute shader mode. And then I try to call compute shader and it's just like, I have no idea what's going on. So I probably just forgot to tell it to stop the graphics rendering. And yeah, so let me fix this one first because this should be easier to fix. So let's see. Yeah, so it's telling me that when I try to run fill buffer right here, this cold indirect count doesn't exist. Oh, right, and that's because I'm calling this at create render graph. Right. So yeah, I can do this with a dynamic node, but that's also kind of stupid. Because I know this is just 4. Like this is just, I know the size of this will never change. So then I can call realloc, and this is just like size of UN32T. So I should fix that problem. And then I think I can actually get rid of it up here. Yeah. That's fine. And so now the other problem is this active render pass issue. But I thought I am, yeah, so I'm going down here and I'm saying end rendering. So maybe I need another barrier or something. Yeah, add node, end rendering. So I'm definitely telling it to stop rendering. But then by the time it like comes back up here for the next frame, it thinks it's still rendering. So I might need like another memory barrier. Not sure what else it would be. Yeah. So let me look here at what I'm doing here. Yeah, so timestamp. So ensure previous vertex read. Oh yeah, see, I don't have this up here. I missed a memory barrier up here somehow. Maybe I put this in the wrong spot. This is shader storage read, vertex shader storage write, shader storage read, compute shader. Okay, so I just missed this one up here. And that should be synchronization actually. And this is memory barrier. So let's see if that fixed it. Okay, draw commands buffer doesn't exist. It's still telling me cannot be called inside a dynamic rendering instance. No, I think this is... Huh. What? That's weird. Draw commands. Oh yeah, indirect commands. So I need to rename this buffer. Yeah, draw commands. Yeah, this should be indirect commands. Yeah. Because the names have to match between here and the shader, and I renamed some things on the CPU, but not on the shader. Okay, so that's gone now. But this is still this problem about the render pass. About calling an active render pass. Dependency info. Pipeline barrier. Dependency info cannot be called inside a dynamic rendering instance. Well, yeah. So there's pipeline barrier up top. But it should have stopped. Or, yeah, like I should have called end rendering. There's not any... Did I, like, miss some arguments to this? No. It's just end rendering with the command buffer. So I call render, I set all the sizes and stuff, and then I tell the render graph to render. Oh, yeah. That's why. I am calling begin rendering up top. Yep. Yeah, begin rendering, end rendering. Yep, there we go. Okay, creating buffers is unsupported. Cold draw indirect count. All right, that's a better error. So cold indirect count. Yeah, I just changed the name. That's all. And yeah, I probably need. Do I have cold draw commands? So I definitely need some better way of managing the names between the shader and yeah, I think we're gonna fail because I don't have like cold draw indirect count now. But yeah, definitely I need some better way of talking between these two so that I don't get these errors all the time. And yeah, really, I can just make it so this is actually supported. But the problem is I don't know how big to make the buffer. I don't know the size of it. So even if I try to like dynamically create the buffer, I still don't know what its size is. And so I'd rather crash here with a clear error than like allocate a buffer with too small of a size, and then I just get like a GPU crash and I have no idea what happened. So like if I had to pick between the two errors I get, I'd much rather get this one. So creating buffers into script updates, unsupported cold draw commands. All right, and so that should just be like indirect count, the same size. So yeah, storage buffer, device local, host visible. It should be cold draw commands, and then I can match the size of indirect commands to cold draw commands. There we go. Let's see how this works now. Hey, okay, it's kind of working, sort of. I think my frustum culling code is broken, or a bunch of the code is broken. But it actually is running my compute shaders, so without giving me any like weird errors. Yeah, so I definitely have some like math issues or something. Like the shader code itself isn't working quite right. Which is understandable because now that I can add and remove objects dynamically, I think that really screwed up some of the assumptions I made with my culling code, and so I expected something like this to happen. But it's actually working. So like I don't know how well this shows up on stream, but you can see like things appearing and disappearing, and yeah, these are like changing colors because I think I'm deleting the material that a whole bunch of these are using. But it actually is doing things. So that's great. So this is a big improvement. This is like the last thing I need to do before I can merge everything. So yeah, let me see. So now it's like the complicated part of trying to figure out what actually is going wrong here. My best guess is I have this problem here. So how the culling code works is a little complicated, but I'll try to explain it. But I might kind of hand wave some parts a bit. So this part here is pretty simple, right? So like the GPU, it's running on like thousands of threads or hundreds of threads or whatever. And so I'm just saying, hey, get the thread ID that I'm running on. And then if that thread ID is less than the buffer count, right? So I'm just like checking the size. And right, so check the size first, and then if it's within the size, then check if that instance at this index is visible, right? So I'm processing one instance per thread on the GPU, so it go really fast. Right, and so now I do this visibility check, and all that's fine. So this is just checking some frustum culling stuff, and I probably can. Right, originally this was like pulling this scale X, Y, and Z. So like right here, how I'm getting the translation. I kind of need to do the same thing for the scale, but the scale isn't as easy to get out of the matrix. So let me see. Can I like decompose model matrix? Matrix decomposition, yeah. This is pretty complicated, especially if I want to do it on the GPU. Like the GLM math library I'm using just kind of natively supports it, but it's a lot more complicated on the GPU. Yeah, matrix decomposition. Yeah, a lot of that goes over my head. GLM decompose and then compose back again. GLM decompose model matrix scale. Decompose it into translation, rotation, and scale. So yeah, here's algorithm for 4x4. You can solve 3x3. Yeah, well, I have 4x4 anyway. So translation is the last column. So scale, take the length of the first 3 column vectors. Okay, so that's how I can get the scale out of it. But I think this is like so I can do this. I also think it's a bit of a less urgent issue because this code was always kind of broken. Yeah. I can try it. I can take the length of it. Is there there should be like len? Is this a thing? Of the first 3 columns? Is that what it said? Take the length of the first 3 column vectors. Okay, I see. So this be float scale x equals the length of the model matrix of 0, scale x, y, z is 1, 2. I don't know if len exists like this, but it should have something for it. Or undo that. Length. Okay, yeah. Yeah, there we go. It's showing up in purple now. That should be right. And then not object scale x. This is just scale x. Scale y. Scale z. And so, yeah, I'm like doing it this way. This is a little slow, but eventually I'm going to use, this is like using sphere frustum culling. Eventually I'm going to switch to using oriented bounding boxes. And so that should be a bit better. But for the moment, I'm just going to do it like that. And so I expect this is still going to look like very broken, but yeah, okay. So I think at least the culling code is right. So it looks, at least to me, it looks a little better. Like I can see more of the, I can see more of the stuff. But yeah, like the actual instances of what I'm trying to cull is all screwed up. So it's definitely something I need to fix. But I think this should work fairly well now. So let me go ahead and commit that. Let me see, what did I actually change? Oh, yeah. Yeah, I'll just throw all this together. That's fine. When optimize, you keep the distance squared during max and do square Square root after. Oh, yeah, something like that. Um, yeah, but it's not really that important. Like it's running like 1,000 FPS, so yeah. Um, git commit. Let's see. Working thrust. I'm calling. Let's see. Draw compaction has errors. So where the real errors are is probably like right here when I'm trying to figure out the number of visible instances in a draw, because on the old engine I could assume that the draws were sorted, but in the new engine the draws aren't sorted because it's kind of part of it is like I can put anything anywhere, and so like I could try to sort the draws first, but that's kind of a bad solution. Um, I like to just get this to work in the first place without needing that. And so it's kind of complicated what I'm doing. And you know what? I wonder, try doing that. You can keep the distance squared during the max, new square root after. Yeah, I could dot them together. See, what's like my frame rate right now? Yeah, I'm getting like 500 FPS, 540. And then if I just like don't do any of this, and I set radius to just be 1, then what do I get? Yeah, I'm still getting 540 FPS, something like that. I wouldn't be surprised if the compiler was optimizing it to if the compiler was optimizing this stuff. But anyway, yeah, because I'm getting like the same frame rate between like manually setting, just forcing the radius, and actually doing this. So this is definitely at least not what's bottlenecking things. What I really want to fix is get this working. And I was thinking about this earlier, and I'm still not sure how I want to fix this. I think probably the first step is I can significantly reduce the number of objects I'm drawing, and then I can just pull it up in RenderDoc, and I can see exactly what's going on here. So this is getting rid of that like extra million cubes that I was drawing. So if I run this now, what does this look like? Yeah, so now I have like this one thing, and I do have some other models. I just don't want to show up. So let me pull this up in RenderDoc, and we can see what's going on. Man. Oh, am I back? Okay. Apparently running this in RenderDoc will like totally freeze my GPU. So yeah, that's not great. Yeah, failed to submit draw command buffer. Yeah, can I just like capture the first frame and then, I have to like capture the first frame and then just tell it to immediately exit or something like that. Let me try this. Or yeah, I've had problems like capturing frame 0. Like I want to go a few frames at least. Let's see. So I launch it. There we go. Okay. So yeah, nothing's getting drawn right now, which, well, I should be having things getting drawn. So yeah, so drawn direct count is still 55. So that's definitely not right. Right, and what are these instance counts? Okay, but then like everything's instance count is, no, you're 20. I hate how, can I like expand all or something? Can I select multiple? No. Expand all? No. That's annoying. Or, yeah, no. because I think so the main problem is if I don't have an accurate number of visible instances, um, then I'm not going to be setting, yeah, so I won't set instance count correctly. But what if I just don't care about that, right? What if I just don't change instance count, right? Then that should just draw everything. That should verify that like the rest of the code is working and it's not breaking anything. Okay, yeah, and then first instance equals new index. And this is what I'm getting from the prefix sum. Draw command dot first instance -1. Yeah, okay, but this might actually be fine. Maybe. Cold material indices. Draw command dot first instance. Yeah, so I'm still going to call materials, but just not objects, maybe. Yeah, and then call draw commands. Okay. Let's see what this does. Just see, if the problem is just visible instance count, right, which I'm getting from visible instances, then I'll know, because like everything will look mostly fine. I think there's still some problems with the frustum colon code itself, and so like some materials that I can see might get culled, but that's a different problem. Oh, it crashed again. Great. Okay, back again. Yeah, so that almost crashed me again. So yeah. Yeah, GPU hung, device lost. Okay, so I'm definitely doing some really stupid things here. Let's see. So like all this stuff should actually work fine. This is doing a prefix sum on the GPU. Basically, this is like getting like the sum of an array. So if you have like 0, 1, 2, 3 is an array, then the sum would be like 0 plus 0, so 0, and then 0 plus 1 is 1, and then 1 plus 2 is 3, and then 3 plus 3 is 6. So it would be like 0, 1, 3, 6 would be the prefix sum of like 0, 1, 2, 3. And so I can use that to help me figure out how many visible instances I have, and then it also helps me. I have to compact them, so they have to be contiguous in memory. So like they have to come like one after another. I can't have any gaps between the different instance data in memory, because how like graphics works is it just and specifically like Vulkan and all that is you just have like an instance index, and so I'm just looking for like the instances after that. So it has to be contiguous, and so like I can call it here, and then the rest of this code in all of this stuff is for actually handling like the prefix sum and calling all the draws and all that. And then I was getting a GPU hang, which basically it's generally what that happens is that I'm like seg faulting on the GPU. But I'm not quite sure how, unless if this like new index is very wrong. So let me not change that either. Oh, you know what it probably is? It's not this. It's that since I'm not setting instance count anymore from visible instance count, but I am still using the but when I'm going here, or really it's this one, I'm still using this cold instance indices buffer, but then this is what actually copies to it. So the instance index doesn't exist, and so I'm trying to like dereference some null data. So yeah, I can't just get rid of it that easily, so that's why the GPU crashed. Yeah, so all this code works, and all of this code works. So none of this is the problem. It's specifically this call draws thing. And if it's anything in here, it's going to be this visible instance count. So I'm going to go ahead and run this. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this visible instance count. And if it's anything in here, it's going to be this Right. Yeah, so prefix sum, draw command first instance. Yeah, so that's getting like the -1. Yeah. Yeah, this is getting like the new first instance from the prefix sum. You know what I can do? I can probably just use like atomic add instead and like do all this in one shader, and that might be simpler. And then I can kind of work from there. I'm not sure. I'm probably just gonna have to think about this more off stream. I was planning on trying to be on for like another at least 20-30 minutes, but I might go ahead and end this early and just kind of think about this some more. I'm also pretty tired because I've been like streaming all weekend. Um, but anyway, let me see. So I'm trying to get the count of visible instances, and I have this prefix sum of all the instances, and these are actually in order. Yeah. And so yeah, I can get the current draw, and I can know what its first instance count is, and its what its first instance is and its instance count. Right, but then I need to like subtract out the previous draw because I'm like pulling it from the prefix sum. So maybe it's not exactly the previous draw. It's like or well, it is the previous draw. It's just that the draws might not be in order. Yeah, so they have to be sorted. So maybe I could try sorting them, but that's also kind of complicated because it's on the GPU. Like I can sort it from the CPU, but it's still it's not great. Yeah, prefix sum has an entry for each instance and it's kept in order. Prefix sum draw commands dot instance count -1 is the sum of all visible instances inclusive. Okay. Prefix sum draw commands -1 is the sum of all visible instances of the previous draw inclusive. Their difference is the number of visible instances in draw commands of draw index. Yeah, so that makes sense. I just don't know how to actually make this work. And so here, like, I'm also doing like if draw next is not equal to 0, else get the prefix sum length, the first instance plus the instance count. I think what this actually needs to be is like if first instance is not equal to 0. Otherwise, just return like the instance count. Yeah, and that's why I have this note here. Probably doesn't need to be offset by first instance. I could try that in the other one and see if it works. But I think this is the real problem: is how do I count? How do I get how many visible instances I have for a specific draw? And so I know what all of the indices are for the draw in the in like the big instance buffer with everything before culling. Then after culling, am I doing culling in screen space tiles? No. I'm just going over every instance and I'm just giving like one so I have instances for everything, right? For like all the models. And so this is just for frustum culling. And so right now I'm just looking over, I'm just giving like one SIMD lane on the GPU per instance. And then I'm just running that over all the instances and seeing which ones are visible. And then, so then I have all that visibility data. Basically, that's like right here in lane active. If you can imagine like lane active being spread across the whole GPU all at once, then this would be like, oh, lane active, if like the 0th thread is active here, if like this is true, then that means that the instance is visible. If it's false, then the instance is not visible. And then the rest of this stuff is just doing like prefix sums to actually count all those up. So I can see how many visible instances I have. And then I can modify the draw commands to change the number of instances that those draw commands are drawing based on this. And then also, like change the like copy. So this will copy the visible instances over into like a new buffer, and then this will copy like the visible materials over. And and it also calls like empty draw commands. But what I'm having trouble with is actually figuring out what the number of visible instances are with my new renderer, because the draws are no longer sorted. And because of that, I can't just like look at the, this kind of explains how it works up here, if this is readable. I'm just kind of looking at the prefix sum and I'm seeing, okay, well, let me look at the previous draw. And then if, if the I'm getting like the number of visible instances up to the previous draw, and then I'm seeing how many like total instances are in like this current draw with the prefix sum, and then I can subtract those out, and then I get the number of visible instances for this draw. Because like the prefix sum, it's like the rolling sum or like the totals, right? So I just have to subtract out the total from the previous draw command from the total of this draw command, and then I get the amount for just this one draw command. But it doesn't work if it's not sorted. It's not sorted anymore. So I can sort it, or I can figure out a better way to do this. Because basically previous draw doesn't need to be like draw index -1. It needs to be the draw that has the Are you issuing multiple draws for the same model? No, I'm using instances for everything. Well, kind of depends what you mean by model, because I'm using GLTF files, and GLTF files could be a little complicated. So they have like, let's see, where is this? Yeah, meshes. Previous simple meshes. Okay, here we go. Yeah, so GLTF files, like you have this one model, and this model can have a whole bunch of meshes in it, and then each of those meshes can have a primitive, and the primitive is what actually has the vertex data, index data, and all the texture, or no, the the instance data, or the vertex data, index data, materials, all that stuff is in that primitive. And then I'm using instancing for everything. So I only have like one, I basically have one draw call per primitive, and everything else is instanced. And so I'm using VK draw index indirect this. So this is what my draw calls look like, and I have like one of these per primitive that's kind of loaded in my scene. And so I have like this first instance thing here, and I can just like set these to whatever I want, right? So like vertex offset this, or just start at the top, right? Index count, that's the count of indices from the primitive. Instance count is how many instances of that primitive I'm trying to draw. And so like whenever I create a new object, just confused why you need to look at several draw commands in the compute shader. So I'm trying to call the draw commands. And so if you look here, the important, draw command, draw struct, the important thing here is this instance count and this first instance. So if I go to my vertex shader, right here, there's this GL instance index variable. What this is whatever I choose to put in first instance plus the like 0 up to instance count for each instance, right? So this would be like first instance plus 0 plus 1 plus 2 plus 3 plus 4 all the way up to like 10 if instance count was 10. And then so that's how I'm indexing into my instances, is with that. And so what I need to do is when I'm calling things, I'm removing instances. And so like I could be removing instances from the middle of the buffer or something. And so I'm also doing like draw compaction with that prefix sum I was talking about in the compute shader. And so anything that's like in the middle, it'll get overwritten basically into this like cold instance indices buffer. But because the number of instances changed, then I need to change the instance count of the draw command. Otherwise, it will go over the limit and like start either trying to draw stuff that doesn't that it shouldn't be drawing, or like just draw random garbage if I haven't like copied it if I haven't copied anything to that spot in the cold instance buffer yet. And then if it tries to like draw that and tries to get pointers from that, then you can get like a GPU crash. Yeah, and so I have to update. You have to update first instance and instance count, and then also I have to update the this cold draw and direct count. And instead of doing like all this complex stream compaction stuff, since I only have like 50 draws, 60 draws at the most, I'm just using atomic add for now. Eventually, if I want like thousands of draws, then I will want to do like the complex stream compaction stuff for actually figuring out which draws to call. But for now, just doing atomic add is fine. It's good enough. So I don't know if that all made sense. If you want to look more like what I'm doing, I'm going to look up like stream compaction. Yeah, this kind of stuff. Yes, there's like stream compaction a lot. Need to update instance count of the draw command. Where does multiple draws come in? Yeah, so I have this prefix sum buffer that's keeping track of all of the visible instances, right? So in my shaders, right, I'm just going to start putting stuff here, right? So let's say this is like my instances buffer right here. And so this just has like a whole bunch of like random instances. It doesn't matter what's in here. Well, I mean, they wouldn't be duplicates, but they can be in kind of any order, whatever, right? These are just like indices into like this buffer full of model matrices I have, and use that for the instance data. All the visible instances of this mesh. Yeah. So I'm trying to figure out all the visible instances of that primitive, technically, if you want to talk about if like GLTF terms, but yeah, of the mesh. So I have all these instances, right? And then I run is visible on each instance, right? And then I take the output of that. Right. And so if you imagine like this is running across like the whole GPU, right? So I could say, so this would be something like 0, 1, 1, 0, 1, 1, 1, 0, 0, 0, 1, something like that, right? This is running, and it matched the number of things here, whatever, right? It's clear enough to understand. So I get all those visible instances, and then I do a prefix sum on it. So I get like 0, 1, 2, 2, 3, 4, 5, 5, 5, 5, 6. So this is like the prefix sum. And then I have to modify the draw commands. And so to actually take into account the visible instances. And so what I do is if I say like, okay, so this draw command, if this thing's first instance, let's say this one is like 2, then I want to start at index 2. So that would be like right here because it's 0 indexed, right? So 0, 1, 2. And then let's say it's instance count. So instance count equals like 3 or 4 or something, whatever. Yeah, 4. So then that means that that's this range from here to 3, 4, whatever, right? So what I'm looking at in the buffer is like is these numbers, and so I'm trying to remember how this works. Yeah, this is like 2 to 4 of the prefix sum buffer, and then I get its like new instance count from saying like maybe there's a better way to do this. Now I'm drawing it out. What I'm currently doing to get the instance count is I'm saying, okay, well, what's the like if I have draw commands, right? What's this of like draw index -1 or whatever, right? And so what that would be is let's just say that's like 0 and 1 because that draw command would be let's say this thing's first instance is 0, and then this one's first instance and this one's instance count is 2, right? And so this is what this one would pull out from the prefix sum buffer. And then if I want to figure out what this one up here, right? So call this like draw command 2, or let's just say like draw command 1, that's like index 1, and here's like draw command 0, index 0. And then if I want to figure out how many visible instances draw command 1 has, then I can take this value here. So I can say dot, what is this? Instance count, right? This can be, yeah, this is like 1 minus, is it 3? Or is it? Yeah, it's like 1 minus 3 or something. Or 3 minus 1. Yeah, it would be what would this be? This is like prefix sum of draw command 0 dot first instance plus draw command 0 dot instance count. Yeah, it's like that, right? So let me put this here, right? So TMP equals whatever this is, right? And then this thing's instance count would be draw command 1 dot TMP2 equals basically this, but of draw command 1. Right, and then this is just like TMP2 minus TMP, something like that, right? And this would be like the new instance count for draw command 1. So I need this, but then I think the other way to do this, right? So then like the instance count here would be, right, so that makes this draw command 1 dot instance count equals 2, right? Which is correct because between like first and like between this, right? This has like 2 instances that actually get drawn, right? It is 2 and it is 3. But then maybe there's a better way to do this, right? Like maybe I can just iterate over all these instances and count it. So instances holds info for all primitives. Yes, yeah, it holds information for all the primitives. It's just one big buffer that I'm putting all of the instances into. Right, and so what I want to figure out right now is how do I get this instance count without relying on like draw command 0 like this, because like because basically how I get that is just by like draw command -1, right? So let's say draw command 0 equals this, right? And I'm expecting this stuff to be sorted in order by first instance, right? Because if it's not sorted, then I just get like random garbage out of here, right? Like I'd be like trying to subtract the instance that's like up here at the top or something from this, and I just get random numbers for instance count. And because like part of like the whole, yeah, and so because I like rewrote my engine to let it like specifically that I don't need to care about sorting anymore. Yeah. This took me forever to wrap my head around. Yeah, some of it was just like me kind of coming up with it on the spot, and other stuff I was like reading a whole bunch of stuff about, like especially like trying to do prefix sum stuff on the GPU. I like could not have done this without all the articles that I found about actually trying to do this, because this actually gets like pretty complicated, and every time I look at it I have to like step through line by line to figure out what it's actually doing. Yeah, but now so these aren't sorted anymore because I want to be able to just like dynamically add and remove stuff, like add or remove models and whatever else. And so I can't really rely on these being sorted, and I could manually sort it, but I think that's just a bad solution overall. I'd rather figure out an algorithm that doesn't need to be sorted, right? And so let's say like I have this 2, 2, 3 here, right? So maybe what I want to do, maybe it's something as simple as like is it like maybe it would be as simple as just prefix sum of draw command 1 dot first instance plus instance count, right? So if I did like draw command 1 dot first instance plus instance count minus prefix sum of draw command 1 dot first instance, and then I think I need like +1 here, right? Because this would also get me 2, because this right here, first instance plus instance count, or yeah, prefix sum. So this is like prefix sum of 6 or whatever, right? So or 0, 1, 2, 3, 4. Hold on, that's not right. Or maybe I copied things wrong, but I think it's something like this could work. So conceptually, you could spawn a compute execution per primitive and do a naive sum of the is visible mask from first instance to last instance. Yeah. So that's what I was thinking. So that's what I thought at first, right? I said like I could iterate over the instances here, but I'm thinking I can probably just like subtract it out, right? Like I can just do like 3 minus 2 plus 1, and that should get me 2. And so I won't need to do another compute thing. But then this doesn't work out quite right, because this is from like 2 to 6. But maybe I like copied this wrong. Oh yeah, because this is instance count 4, not like last instance index, right? So if I just say instance count 3, because that's 3. Okay, so hit the first instance 2, so that's 0, 1, 2, right? And then right, and that instant count, so it starts here, so it says 1, 2, 3, right? And so that would be 5 down here. So yeah, that's 5. And then I said prefix sum of 5. So 3 minus first instance, which is prefix sum of 2. So 0, 1, 2, which should get me 1. And then I just add 1 to it. Now, I don't know if like I always just need to add 1, or if that's just like some weird trick that worked this one time. Let me think about it, because maybe yeah, it might be that add 1 always works, right? Or let's say like I had an instance that took like this block here, that was like from here to here. And then I did, yeah, like 3 minus 5 is 2, plus 1 is 3. Yeah, all 3 instances are visible. So I think this will work. Let me turn this into a comment. Right. Yeah. Let me try it like this. Right, and so this needs to return prefix sum of, yeah, it's not that, it's draw command equals, yeah, so let's just say draw command equals draw commands of di, so then draw command of first instance, draw command of instance count, draw command of first instance plus 1. So let's see if this works. And yeah, and actually like kind of explaining all this to you pretty much helped me figure this out, because I just had to go through step by step of what exactly this is doing and kind of draw it out. So that's good. I understand it better now if this doesn't work. So let's see. This might crash my stream. I don't know. It didn't crash earlier, but I think it froze for a bit. But anyway, so I might crash. You know, I don't know. Okay, that's... Oh, yeah. Come on. You can do it. You can... Okay, there we go. I'm back. Yeah, it froze me. I don't know if like I was actually frozen on stream or if like my screen was just frozen, but in any case, like very much screwed something up. Yeah, so GPU hung, error, device lost. So then I guess what I can do, so let me go ahead and commit this. Yeah, that's fine. And let's say possible working, still get audio, screen was frozen. Okay. Possible working visible instances. Okay, and I want to commit this, and then I want to switch to my old engine because like this, my engine rewrite, and I want to see if this code works on the old engine, because if it does, then I know that like at least this part works. So copy that, switch master, and go here, and then, or yeah, it's actually this one. Just put that in there. So then compile and run this. Draw commands. Yeah, well, that's right. Okay. And I'll probably be on for another like maybe 15 minutes. I do want to take a break. I might be back later. I think on my schedule I'm set to be back later. So if I do take a break, I will come back later, like an hour later, because I think I'm like off an hour on my schedule today, or maybe it's an hour and a half now. I don't know. But I do want to